Hi, everyone. My name is Eugene Stepanov. Thank you for inviting us over, and thank you for coming. As I said, name's Eugene Stepanov, and I'm a senior database solution architect with AWS. Here at AWS, I focus on all things SQL Server and Postgres. And today, I am accompanied by my colleague, by my teammate, Aditya. Aditya, you want to go ahead and introduce yourself?
Sure. Thank you, Eugene. My name is Aditya Samant. I am also a database specialist solutions architect on Eugene's team. And I specialize in Microsoft SQL Server along with some other databases. And I have been here with AWS for about 2.5 years now. And I've been working with databases for about 17 years or so. And I've held pretty much every imaginable role in database world, including a DBA, a database architect, infrastructure architect, database consultant, and then so on and so forth. And very excited to be here and share this information with you guys. Back to you.
All right. Thank you very much, Aditya. And as Aditya, I've been in IT industry for 20 plus years. I've been in database development in front-end, middle tier, as well as back-end development. And since about 2006, I started focusing on back-end development pretty much exclusively. So I work with every single version of SQL Server since 7.0, and that's a long time. All right, with that, let me share my screen. And now you should see my presentation. As I mentioned, the focus of today's webinar would be running your production SQL Server workload on Amazon RDS. And just to remind you, this is the third episode in a series of episodes called Move to Managed. So far, Gauri and Kathy took us through a Postgres story. They told us how to run your Postgres workload on RDS, and later Kathy showed us how you can migrate your self-managed Postgres workload over to RDS for Postgres. This presentation, today's workshop, will be all about SQL Server, and we will take a careful look at what are these built-in features that make up RDS for SQL Server. And then on Wednesday, there will be another SQL Server focus session, but focus of that session will be how you migrate your self-managed workload over to RDS. And later, we're going to do similar sessions for MySQL and for Oracle. So please stay tuned and join us. With that, learning objectives. So we have a lot of ground to cover. I'm hoping that by the end of today's workshop, you will understand the value proposition of Amazon RDS. You will learn how to provision and how to configure RDS SQL Server. We will also take a careful look at the built-in features such as high availability, read scale out, backup security, and so forth. So with that, prerequisites for this workshop. We will have lots of hands-on. So obviously for this, you need AWS account. Every AWS account comes with a default VPC, and that's where I'm going to be deploying my resources. You're welcome to do the same, or if you wish, you can provision your test VPC and deploy your resources there. The third one, we're going to need at least one public and at least two private subnets. This is a database workload, so I'm going to be deploying those into the private subnets. This is the best practice. This is security best practice. You don't want to be deploying your databases into a public subnet where it's accessible from the internet. But in order for us to access and to interact with those instances, we're going to have a jump box. We're going to have an instance sitting in the public subnet, which brings us to point number 4. We're also going to need a Windows jump box sitting in that public subnet with SQL Server Management Studio installed on it. I hope that makes sense. And here are the instructions. Obviously, use your AWS account, log in to it using your IAM credentials. I will be deploying my resources in US West 2 Oregon region. You can do the same, or you can select any other region of your choice if you wish to. I'm going to be executing a couple of scripts for the hands-on part, and that's where you can download those scripts. There's a Bitly link there. And also, as already been said, we have a group of very seasoned, experienced SAs here with us today. So don't hesitate. Use that chat function. Ask us if you had a roadblock, if you have a question, and we will try our best to answer all your questions in real time. Thank you. With that, Amazon RDS. Well, for those of you who are not familiar, RDS stands for Relational Database Service. And a relational database service has been built with a single mission in mind. And that mission is to free you up, you, our customer, from a very task-consuming operations, such as provisioning hardware, installing operating systems, installing database engines, maintaining them, applying security patches, configuring them multi-Z, configuring the high availability solutions, configuring sound backup restore strategy, monitoring failovers, all these tasks that take a lot of time for our system administrators and database administrators on a daily basis. So you can free up those very valuable IT resources and redeploy them to the project that deliver value to your customers or that differentiate your business from the competition. And RDS supports very popular commercial engines such as SQL Server and Oracle, as well as most popular open source engine, MySQL, Postgres, and MariaDB, as well as our own. On the very left there, you see Amazon Aurora. Amazon Aurora is another engine that is supported by RDS, and I see a lot of confusion in the field. Some folks under the impression that Aurora is not part of the RDS. This is not true. RDS is just another engine that happens to be our own. And Amazon Aurora comes in 2 flavors. It comes in MySQL flavor and Postgres flavor. All right. RDS, since the launch, has been very, very successful service. I'm not going to read that slide. Please take a second, look it over, and I'm sure you'll recognize some very, very big names, and that's just the tip of the iceberg. This is one of the testimony. This is one of the our customers, Rovio, and for those of you who are familiar, Rovio is developer and a publisher of the very popular Angry Birds franchise. And with the launch of Angry Birds 2, at the peak, they were onboarding 120,000 new users every hour, and they're very happy that they use RDS, and you can read the testimony yourself here on the slide. All right. SQL Server. When it comes to deploying your SQL Server on AWS, essentially you have two options. And on the right, you see SQL Server on Amazon RDS, on Amazon EC2. And it all comes down to who's responsible for what. So if you own EC2, then hosting and running your database workload is not too different from the way you've been running your workload and maintaining that on-prem. So we, AWS, will be responsible for the hardware and for the initial OS installation. But after that, ongoing OS patching, ongoing OS maintenance, management, and database management system patching and maintenance, backup and recovery strategy, high availability, scaling, all of that is your responsibility. Now contrast that with the left diagram, and that's what you get out of the box on Amazon RDS. We, AWS, will be responsible for all of those tasks, and hopefully by the end of the discussion, you will be able to do to configure high availability, a backup strategy, and recovery yourself on RDS. All right, this is what's available. This is what we support on RDS. We support all officially supported engines, 2012, 14, 16, and 17. 2019 coming very, very soon. It will be also supported on RDS. Obviously, on EC2, there are no limitations. As long as you have licensed media, if you have SQL Server 7.0, you can absolutely install it, and we're not going to ask why. In terms of editions, we support Express, Web, Standard, and Enterprise. Again, on EC2, it's you are the master of your own destiny. For high availability, it comes to you again as a self-managed experience, and we will spend some time looking into it today. On EC2, it's all self-managed. As far as encryption, we support all native built-in features, SSL, TLS, TDE, always encrypted, as well as EBS storage level encryption, and we will take a brief look at that later today. Authentication. For those of you who worked with SQL Server before, you're probably using something like Windows integrated authentication, and it is supported here as well on both EC2 and RDS. And as far as backups, I mentioned that before on RDS, that's our responsibility. It comes to you as the managed experience. On EC2, it's all self-managed, and the same can be said about the maintenance. All right, building blocks of RDS. It's very important to understand what are the underlying components that will be used for that configuration. As you probably aware, we AWS have hundreds of instance types available to our customers. Now, out of that gamut, we select for RDS only those that do make sense for a database workload. So, for those of you who are not familiar, we go by families. So, for example, M family, M is our general purpose instances that's suitable for the wide variety of workloads. And our R family is our memory optimized family. Now, if you compare, let's say, X large in the M family, that comes with 4 vCPUs and 16 gigs of RAM. The same T-short size, the same T-short size, the X large, in our family comes now with 4 CPUs and 32 gigs of RAM. And if you need even larger memory footprint, you can take a look at our X1E family that now has 122 gigs of RAM. We also have Z1D family, which is our CPU optimized family, and those are built using very fast 4 gigahertz Intel chips. But as far as CPU to memory ratio, they're very similar to that of R5 family. And for the smaller workloads, we have burstable T2 and T3 family also available. All right. The second most important part of the any database system is storage subsystem, obviously. Here on RDS, we utilize elastic block storage, or EBS. And essentially what that is, it's a solid state device that is attached to your instance over the network, but it presents itself to the operating system as a block device. And all that OS sees is the block device. It formats, it puts NTFS on it, and from that moment on, this is just a file system. Now, when it comes to EBS, we have two different storage types. One is general purpose, GP2, and another one is provision IOPS. And essentially, the general purpose one is suitable for a wide variety of workloads and a very cost-effective storage subsystem. It is SSD-based. For high-intensity I/O database workloads, we definitely recommend provision IOPS. And again, provision IOPS on the right, that's a SSD storage, backed by SSD storage, but it is possible to scale your IOPS independently from the volume size, and that's what differentiates that from the general purpose storage.
So Eugene, a quick question for you.
Sure.
What is the difference between these two tiers, given that they're both SSD? Why do they have these different characteristics?
Well, it's important to understand, even though they're backed by the same hardware, you're not dealing with the hardware, you're dealing with the service. So you need to think about these building blocks in terms of service. And these are two different tiers. Those are two different storage types that have a different characteristics. So, for example, general purpose, essentially, it's impossible to scale your IOPS independently from the volume size. In a provision IOPS, it is possible to scale it independently. Now, if you look at the very last bullet point, general purpose delivers performance 99% of the time. Provision IOPS, on the other hand, is designed to deliver performance 99.9% of the time. So the standard deviation of actual delivered performance is much tighter. And again, yes, they both backed by SSD devices, but two different services.
That makes sense.
All right.
Thank you.
All right. With that, let's go ahead, jump to the console, and let's create our first SQL Server instance. All right. You should see my screen now. I'm here on the RDS console, and I myself personally work a lot with Postgres and SQL Server. So you see quite a few instances here deployed in my account. So let's go ahead and create a new instance. As I mentioned before, 6 different engines available. We pick SQL Server, obviously. Let's pick Enterprise Edition. And here in the version dropdown, you can pick, as I mentioned, on RDS, we support all officially supported engines starting from 2012. I'm going to pick the latest one. This template selection, it just controls some of the default settings for the form. So I am going to give it a distinct identifier. Workshop. I'm going to give it our master user a password. I'm going to confirm my password. And now we're coming up on the database instance size. And as I mentioned before, a couple of different families available. There is a standard class with our M family. And there is a memory optimized classes such as R5, X1Es, and Z1Ds. So I'm going to go ahead with standard class. I'm going to leave it to default M5X large. That's 4 vCPUs and 16 gigs of RAM. Here's the storage subsystem. And as we mentioned, there is a general purpose option and then provisioned IOPS. I am going to leave it with provisioned IOPS. 200, 1000 provision IOPS. I'll leave that to default. I'm going to uncheck storage auto scaling. This is just a feature that allows you to auto scale your storage as you're getting close to the limit. Here we're coming up on availability and durability. This is a very important feature of RDS, arguably maybe the most important, depending on your situation. And we're going to spend some time later, but jumping ahead, essentially if you select no, we're going to deploy a single standalone server in one of the availability zones. If you click yes, we're going to deploy not only the primary, but we're also going to deploy a synchronous hot standby in another availability zone. And for those of you who are not familiar with the term availability zone is the logical group of data centers. And the way we design availability zones, the different availability zones are sitting on the different floodplains and the different power grids to give you that resilience in the case of a natural disaster. So for now, let's go ahead and do no. Here we're coming up on the connectivity. I'm going to deploy to VPC. Again, VPC stands for Virtual Private Cloud. This is your fully isolated part of AWS Cloud. And if I open up here additional connectivity configuration, I'm gonna pick my private subnet group, and we briefly chatted about that already. Here we're coming up on the security groups, and I am going to pick one of my existing security groups that I have for my private SQL Server deployments. And security group is nothing but a virtual firewall. Essentially, it lets you open up certain ports and certain protocols to come through. All right, I will have no preference for my availability zone, and I will leave my port at the default 1433, but you can absolutely change that if you need to. Here we're coming up on the Windows authentication. As I mentioned, Windows integrated authentication is supported on RDS, but we're not going to do it for this workshop. But in case you need to join to the existing domain, this is where that is. And here on the additional configuration, let's open this up. It's a big section. It starts with database parameter groups and option groups. I'm not going to touch on those. On Wednesday, Aditya will go into great detail on how you build your own parameter groups and option groups but essentially that's the way to reconfigure your instance. Those are instance level configurations. If you want to reconfigure, you have to go through the option groups and parameter groups. I'm not going to change the time zone or collation. Here we're coming up on the backups. Again, very important.
Quick question. I think that we should take this question real quick. The question is, what options are being used for this high availability? Are we using lock shipping, mirroring, availability groups? Can you talk about that a little?
For multi-Z, let's hold that for another 10-15 minutes, and we're going to go into the details on how we implement multi-Z. Essentially, it depends on the version and edition of the SQL Server you pick, but it's common.
Thanks.
All right. Yep, absolutely. So, as I said, those of you who deployed a sound database backup and recovery strategy know how many moving parts are there. Here on RDS, it's a managed experience, and it all essentially comes down to this checkbox and this drop-down, right? You enable your automated backups, and then you can pick the number of days, anywhere from 0 to 35. 7 is being default. And we will maintain the unbroken chain of backups for that many days. That's all you have to do on RDS. And here you can select the window for us to take that backup. All right, here we're coming up on the encryption. I'm not going to spend too much time here. Essentially, with SQL Server on RDS, we support all native built-in features like always encrypted, TDE. But on top of that, you have also EBS encryption. And those of you who deployed TDE before know how many moving parts there. Here, EBS encryption is very similar in the sense it's using exactly the same advanced encryption standard 256, but it is a whole lot more easier to set up because it's just a checkbox. It's this checkbox. It's literally that easy. And the performance overhead that comes with, that is associated with the EBS encryption is close to nothing. We built our own hardware in order to leverage the hardware acceleration for this function. So today, there is no really good reason not to have this enabled. Performance insights. We will spend a few minutes looking at performance insights. As name suggests, this is just a performance tool, and we will take a look later how that works. And I'm going to leave everything else to its defaults. I'm going to uncheck enable deletion protection. And we're pretty transparent on the cost. So here at the very bottom of the screen, there is estimated monthly cost. So we're back here in the console. And as you can see, our instance that we just created is now creating. It's going to take a few minutes. We're not going to wait. We don't have that much time. But essentially, it's going to take, if I were to guess, 20-25 minutes. It's going to turn to green, and it will be available. So with that, let's go back to our PowerPoint. Hopefully, you see how easy and how fast is it to provision your SQL Server. And essentially, it takes the whole thing end-to-end 25-30 minutes, and you can install a brand new instance and you can connect to it. Now, I spoke a lot about the managed experience, and you're going to hear that term again and again. And what essentially it means is that a lot of these tasks that our system administrators and database administrators spend a lot of time on come to you as the managed experience. The first of all is automated backups. Now, again, you just saw how easy it is to configure the backup strategy, and we will take care, we AWS, we will take care of the rest. Now, the way we build our backups is that we take full EBS snapshot every day, and then we take T-log backups every 5 minutes. So that gives you an idea of that granularity for the point in time restore function that's available on RDS. And again, you can pick any number of days, anywhere from 0 to 35, and 7 is being default. Now, on top of the automated backups, we also have manual snapshots. Manual snapshots are similar to the automated backups, but essentially you manage the entire life cycle of the managed snapshots. And you trigger on your own schedule the snapshot. And for example, automated backup, the longest amount, the highest amount a day is 35. Here, with the manual snapshot, if you want to, you can keep it indefinitely, but we will charge you for the storage. Now, our offer, our service wouldn't be complete or well received if we would not have native backups available. Native backups being such an important part of the SQL Server ecosystem that I think it is very important to be aware that we're not taking away native backups from you. It's still very much available, but it works slightly different from the way you work with native backups on-prem, because here on RDS you don't have access to the underlying operating system and underlying file system. So it works through the S3 bucket. And essentially you execute this command on RDS, and we will produce your native backup and we will place it in your S3 bucket. From that, you can download it, you can bring it on-prem, you can bring it to another cloud provider. It is yours. And it also works the other way around. You can back up your on-prem database, you can grab that native backup, and you can put your backup into S3 bucket, and then there will be a reciprocal command. It's just going to be called RDS restore a database. You run that, and we will restore your database on RDS. And that's one of the most this is one of the most popular strategies to migrate over to RDS. All right, now we coming up to our second demo. All right, here we're back on the console. Let's check on our instance how it's doing. It's backing up. All right, so we're doing some progress here. So let's go to snapshots. So you can see right now I don't have any snapshots, so why don't we go ahead and take one. So I am, for example, gonna take a snapshot of my instance 1, and I'm gonna say virtual workshop instance 1 snap. All right, this process is gonna take a few minutes, and you can see the status here is creating. But in the meantime, let me go back to the dashboard and answer that question that came up through Chime. And essentially, if you explore this dashboard, you will see a lot of columns, a lot of interesting information. And here's the very last column. It's called multi-AZ. It's very simple, right? Yes or no. And again, jumping ahead, when you see no, it means all you have is standalone instance. If you see yes, it means that we will have a secondary hot standby, and we will monitor and we will maintain that hot replica. Now, in the parentheses, you see mirroring or always on availability. Now, you don't have control over that choice. The built-in native technology, whether it's going to be always on availability group or the mirroring, will be picked automatically depending on the version and the edition of the SQL Server you pick. So for 2016 and for 2017, I will have that on my slide. But for 2016 and 2017 Enterprise Edition, it's going to be always on availability group. For anything else, for the standard editions and for the older versions of Enterprise Edition, we're going to have database mirroring backing up that multi-AZ deployment. All right, let's go back to our snapshots. It is still creating. All right, so it's going to take a few minutes. I'm going to come back to it. Let me go back to the PowerPoint. And let's now take a look at the diagram. And this is what I just showed you on the console and explained, right? Essentially, always on availability for 2016 and 2017 Enterprise, and database mirroring for standard and 2012 and 2014 of the Enterprise editions. Again, it's going to be a synchronous hot standby, which means that which enables the no data loss scenario. Both automatic and manual failovers are available. And here's the last bullet, very important one, and it creates a lot of confusion for lots of folks. That second hot standby is high availability purposes only. It is not possible to send your read traffic against that standby server. So if you do something like application intent read only on your connection string, you can't do that. It's essentially, this is off limits for exclusively reserved for high availability purposes only. All right. Now, this is very important slide. Multi-AZ and always on availability group is very complicated topic, and we can be talking for hours just about that. But I felt like this is very important slide, and I wanted to share it with you. I'm not going to talk about all the cases, but take a look at the last column. For those of you who are familiar with always on availability group, you know that AGs come with always on listener endpoint. Now, we will expose that listener endpoint to you. And if you use that endpoint to connect your application to your database, and if you use relatively modern ADO.NET driver, Microsoft started supporting this multi-subnet failover setting since version 4.5, I believe. And if you enable multi-subnet failover equals true on your connection strings, you can expect a failover time to be essentially you can expect it to be single digit seconds. I've seen it as fast as 5 seconds. But then, of course, you can rely on the primary DNS for the always on failover. And in the case of mirroring, primary DNS is really the only option for the failover. Then the times will be much greater. All right, with that, let's have our third demo, and that demo we will take a single instance and we will convert it into a multi-Z, and later we will experience a failover. All right, let's go back. Let's go back to our databases. All right, I am going to pick one of these instances that I have. Oh, and by the way, our virtual workshop instance 6 is now fully available, and we can connect to it. Actually, let's go ahead. This is currently not deployed in a multi-Z fashion. So let's go ahead and let's reconfigure it. So it's here. You click on the modify button, and it's going to take us to the screen very similar to the one we've seen before. And here, all you do is you click yes, right? We were single AZ before. Now we click on yes, and that's it. And again, those of you who deployed always on availability group or failover cluster instances, you know how many moving parts and how many how involved that process is. Here on RDS, it's just a click of a button. You go from no to yes, you scroll down, and you click continue, and that's gonna summarize the change, right? So we're going from no to yes, and we're gonna apply immediately. Click on modify database. All right, let's refresh the screen. And in just a second, we will see that flip to modifying. So here, now you can see it's modifying. So that's going to take a few minutes. We're not going to wait. Let's go ahead and let's pick one of my instances that are already available, such as instance 5. So we scroll down. There will be a whole bunch of very important information about this particular instance, but what we're interested in is here. On the connectivity and security, we've got listener endpoint. We've got listener endpoint and the port. So let's copy that. All right, before we do this, let's connect to our jump box. As I said in the prerequisites, I have a jump box here that I'm going to use, and let me connect to it. So I'm going to copy my password. All right, it seems like my IP has changed. So what I'm about to do, I am about to modify my security group to allow that traffic to come through. All right. All right. So here's my jump box. I already have Management Studio installed on it. And now let's go back to the RDS. And let's grab that endpoint that we were looking at earlier. So we said we're going to grab the instance 5 listener endpoint. Go back and let's connect to it. By the way, you can tell that it's a listener endpoint because there is a word listener in the endpoint itself. I'm going to type my password in here. So we are connected. We are here. It's an empty instance. The only database you see here is RDS admin. RDS admin is part of our control plane. This is not something you have access or control to. It is always there. So what I have here, I have a script. And by the way, those of you who want to follow, you can grab this script out of that document that you can access using that bit.ly link that I talked about before. So it is a very trivial, very simple script. All that's going to do is it's going to create this tiny database, and we're going to create one table. Here's table, it's created. And let's insert 5 records in it. All right. So 5 records is inserted. And let's confirm that they're there. 5 records are here. And now let's capture the net bias of the server that backs the endpoint right now. So let me put it here. Let me erase this one. So right now, the endpoint that we connecting to is being served by this server. Now, let's go ahead. Let's go back to the console and let's inject a failure. Let's reboot. And there is an option here. You can reboot with a failover. Now you click reboot. Let's go back to the databases. And now you see the status of our instance is rebooting. Obviously, that's going to take few minutes, right? This is an instance reboot, but we don't need to wait because we have multi-Z deployment that being backed by Always On Availability Group, and because we connecting by the listener endpoint, we can't just go back to our script and try to query the endpoint again. It seems like it's returning 5 records, but now let's capture the again the name of the server that backs the endpoint, and you can see that the name is different now, and it's reason is obvious, right? We just experienced the failover. Now what used to be hot standby is now new primary, and after the reboot, the old primary will be a new hot standby, right? So with that, let's go back to our console and let's refresh. And by the way, the box is now rebooted and it is fully available. Now let's check on the snapshot that we have created, whether that's available. Now our snapshot is available, the one we triggered. Let's go ahead and let's try to restore from that snapshot. So it's here off of the Actions menu. You click Restore Snapshot, and it's going to take us to the form very similar to the one we've went through. The engine, we're going to leave it at standard. License included is the only licensing model available in RDS. Bring your own license for SQL Server is not supported. And let me give it an identifier, and I'm going to say snap restore, and I am going to deploy that in the default VPC, and I'm going to pick the private subnet group, and I'm again going to pick my SQL Server security group where I have TCP 1433 enabled. And I'm going to leave everything else to its defaults. Click Restore. Let's click Refresh. And now you see this instance is being creating. It's been created. All right. So I hope by now you realize how simple it is to configure your backup strategy, how simple it is to restore from the snapshot, and how simple it is to take your standalone instance, convert it to multi-AZ, and God forbid something happens with your primary, that you have that guarantee of our highly available deployment. And again, be aware that second hot standby will be sitting in a separate availability zone, which is another data center somewhere on another power grid and another floodplain to give you that resilience and that peace of mind. All right, how are we doing on time? We're about an hour into it, and let's go back to the deck. All right. Our customers loved the way we made so much easier for them to deploy HA solution. They loved their ability that we just explored with just a single click of a button being able to deploy that second standby. But the feedback was, it is awesome, but we also really need ability to offload the read traffic over to the read replica. And we listen our customers' feedback, customers like you, very, very carefully, and we take it very, very seriously. And with that, straight out of the oven, we launched SQL Server read replicas on April 3rd of this year. It's a relatively new feature. And essentially, for those of you who are familiar with availability groups, you probably have also a term distributed availability group, and that's the technology that backs read replicas. So without going into much details about how it is implemented, let's talk about some of the prerequisites and some of these limitations of the read replicas. So it is enterprise edition only. It is available only since 2016 Service Pack 2 and Cumulative Update 3, and it translates into that build number you see on my screen right now. It's this build number. You have to be at least at this build number or higher in order to be able to deploy read replicas. If you're on older versions, this feature is not available to you. You have to be already deployed in the multi-AZ, and you have to have your automated backup retention set to any number greater than 0, right? Those are the prerequisites for being able to use that API. Now, important to mention some of these limitations. First of all, it's in region only. As of right now, it is impossible to deploy your read replica in a separate region. You can have only up to 5 of them currently, and those are asynchronous only. You cannot change that behavior. Running synchronous replicas is not an option at this point. And the separate endpoint is very important one. Oops, apologize. It's a lot of confusion for a lot of people. In that here on RDS, every read replica comes with a separate endpoint. So it is impossible to get to the read replica through the primary endpoint, listener endpoint through the primary, right? So if you connect to the primary and you do application intent read only, don't expect that traffic to go to your read replica. In order to take advantage of this read replica, you have to be connected via this separate replica endpoint. And there is no failover, but there is a promotion. There is a promotion process that's available with the read replica. So with that, let's...
So Eugene, what's the difference between promotion and failover? Did you get the question? I was wondering, can you talk about the difference between failover and promotion? What's the difference there?
Absolutely. It's a great question. Essentially, promotion is very different from the failover. The way failover works, you can fail over and then you can fail back. Failover doesn't change the topology of your cluster. On the other hand, what promotion does, it completely breaks apart the cluster, and by the end of the process, what you end up with completely separate standalone instance that has no relationship to the original parent cluster. So from that sense, they are very, very different. All right. All right. Let's go and let's have our fourth demo. All right, let's refresh the screen. Our restore is still creating, and our instance number 6, the one we converted to multi-Z, is still modifying. All right, so let's go ahead and let's pick another instance that's available that is already multi-Z. So for example, this one, we've got always on, and that's instance number 5. Let's go ahead and let's click on Actions. And here, off of the Actions menu, you see Create Read Replica. And again, screen is very similar to that you've seen already. And I'm not gonna talk about all of these configuration parameters, but just want to mention one thing. Here's the power of Read Replica. Your Read Replica doesn't have to be sized exactly the same way your primary size. So maybe, depending on what you're doing, maybe your plan is to send real intense read workload, and maybe you want your read replica to be larger than your primary. You can absolutely do that. And the same story with the storage subsystem. You don't have to match the configuration of your primary. You can absolutely provision more IOPS, for example. So let's go ahead, scroll down. Again, I'm not gonna talk about a lot of them, but let me give a unique identifier for this read replica. Instance 5, read replica. All right. I'm going to leave 1433 as the default, scroll down, leave everything to default, and let's go ahead and let's create read replica. Ooh. There's typo here. Right? Database instance already exists. All right. Say number 2. All right. So let's refresh. And we're going to see here for instance 5, our second read replica being created. All right. With that, let's jump back to our PowerPoint. So I hope you just saw how easy it is to deploy the read replica. I don't have much time. I have just a few minutes left, and I have one more demo I really want to share. But essentially, how easy it is to deploy that read replica and connecting to it. I mean, there is a endpoint. You grab that endpoint and you connect to it via your management studio or your application. All right, let's go to the next slide. And another very important aspect of the RDS and the promise of the managed platform is the fact that you can very easily scale up, scale down your instance types, as well as changing your storage subsystem. Now, contrast that with your situation in a traditional setting where on-prem, and we've all been in those shoes, right? We've outgrown the physical capacity of our box. We need to provision new box. We wait a few weeks. Then we can install our operating system. Then we can install database engine and start configuring our application. Here, and again, by now you've seen how easy it is to deploy resources, and it's as easy to change them. So if you find yourself in a situation where the number of CPUs or the amount of RAM is not sufficient anymore, your business grew, it is very easy to scale up to match the workload of your business, the actual workload of your business, as well as scale down. Maybe there are some seasonal patterns, and for some part of the year, maybe you could take advantage of the small instance size and optimize on cost. And the same can be said about the storage, especially with the provision IOPS, where you can easily change the number of IOPS. You can also do it here. All right. Performance monitoring. Next topic of this discussion is performance monitoring, and performance monitoring is a huge topic. And I realize that we could probably talk for a day just about performance monitoring. Now, those of you who have worked with SQL Server before, you probably rely a lot on the SQL Server native functionality, such as DMVs, DMFs, maybe SQL Server Profiler, maybe extended events. You uh, obviously looked at the execution plans using SSMS or maybe a third-party tool, and you probably also leverage some of the tools that's available in the community, as well as the commercial products like SentryOne, Redgate, set of scripts by Ola Hollengren. Those are very popular as well. So I just want to mention that these options are still here on RDS. Most of the native tools are still available, and you can absolutely use those tools. Third-party tools are also available, and a lot of the vendors recognize RDS as the very important platform, and they adjust their tools to work with RDS. So, for example, as this slide suggests, the Ola Hollengren and the SentryOne. I myself tried quite a few Ola Hollengren scripts, and they work like charm on RDS. And SentryOne tool has an addition specific to RDS. Now, that's what you used to do. Now, on top of that, there are new things you can leverage. The number 1, 2, and 3. Amazon CloudWatch, enhanced monitoring, and performance insights. Now, I am going to, let's jump straight to the console. And let's refresh this. And let's go ahead and connect to my second jump box. All right, I need IP. So here's my public IP. Right, let's now grab the password. and let's connect to it. All right. I am here connected to my instance number 4. And if you download that script, if you follow that bit.ly link, you can download that script. And the second script, on that document, what it does, it essentially builds, here's the script, it builds a test schema. There are three tables: posts, users, and votes. And it loads those tables with the random data. So here's the script. I'm not going to execute it now. I execute it prior to this workshop because it takes you a few minutes. I generate some data, and then this script gives you this USP random queue storage procedure that can generate some workload against your deployment. So what I'm going to do, I'm going to execute I'm going to open up few sessions, and I'm going to execute few parallel sessions and have load on them. All right. So we are going to wait a few minutes, but in the meantime, let's go to our console again, RDS console. And let's talk about CloudWatch metrics, enhanced monitoring, and performance insights. Again, going back to the presentation slides, that's number one, number 2, and number 3. That's what's available on RDS on top, above and beyond what is usually available for SQL Server, right? So the first one is CloudWatch metrics. Let's go click on instance 4. And let's click on monitoring. Here on monitoring, you see few metrics. It's important to remember that CloudWatch metrics are hypervisor level metrics. So you can play with this. You can take a look yourself, and soon as our workload ramps up, we will see these charts spiking up. But essentially, 11 hypervisor level metrics available in the CloudWatch, right? CPU utilization. You can read yourself the rest of them. I'm not going to read about all of them, but CPU utilization, number of connections, and queue depth. Very, very important. Queue depth. That's the metric that gives you visibility in the storage subsystem and whether you queue in on your storage subsystem or not. So very, very important. Now, the second tool available with RDS is called enhanced monitoring. And in enhanced monitoring, what it is, it's essentially they look exactly like the CloudWatch metrics. The difference is that enhanced monitoring are a set of telemetry metrics that's been collected by an agent sitting on the operating system. So again, CloudWatch, that's the hypervisor level metrics. Enhanced monitoring, these are the operating system level metrics that give you visibility into things that's impossible to look from the hypervisor, the memory, for example, right? Very, very important. Now, you also have OS process list. Process list is here, and it's very similar to that of a Process Explorer. You've got the operating system processes here. Now, with that, let's jump to our last tool, and that is Performance Insights. So Performance Insights, our built-in tool that And if you worked with SQL Server before, you probably worked with a lot of different third-party tools. And I would say few things set performance insights apart from those tools. The number one is that we were able to boil down performance to a single metric, which is called average active sessions. And not only that, we can visualize and we can slice that average active session metrics by different weights. And by the way, you can see now our workload is going up, right? So it was period of inactivity, and now we see in the workload because we kicked off a bunch of those scripts. So, and you can now slice that average active sessions by weight, by SQL. You can see which SQL contributes the most. You can also slice it by hosts. And well, in my case, I have only one host. And you can slice it by users. In my case, again, it's just me. So again, single metric, average active session, which can be sliced by weights, SQL, hosts, and users. And performance insights, as long as 7 days of telemetry is enough for you, is essentially a free tool for you on RDS. If you choose to keep your telemetry for longer than 7 days, then we will charge you for the storage. But up to 7 days, great tool to use, no charge. And one more thing, at the very beginning, I mentioned that RDS supports 6 different engines. Now, Performance Insights tool is the same tool whether you work with SQL Server, Oracle, Postgres, MySQL, or MariaDB. It look and feel is the same, behavior is the same, experience is the same. The only thing that it is different is the weights, the weight types. Weights are engine specific, therefore you will see a different weight types if you work on Postgres or MySQL, for example. All right, so that's performance insights. And with that, let's go back to our
Eugene, there's a question on BI and if there's any performance overhead of enabling BI.
Great question. Is there any performance impact associated with enabling performance insights? In our testing, we determined that the performance overhead close to 1% of one vCPU, which means it's close to nothing, really. And the reason it's a long story, but essentially the reason is we're not profiling your workload, we sampling it. We sample your workload every second, and that what makes it so much lightweight. And we only scan the memory structures to build that average active sessions. All right. Aditya, is there any more questions?
I think most questions are already answered here. Were there any questions that we were not able to answer? I'm just going through them real quick.
All right. Then let's move on. We have about 6 minutes left, and there is one more topic which is super important, and that's security. So by the way, let me refresh this screen before I lift the console. And we see our Replica 2 is
so Eugene, after a bunch of questions showed up. So one of the question is if there is a data transfer cost for read replicas in the same AZ.
Aditya, could you repeat the question one more time?
Yes, if there is a data transfer cost for read replicas.
Is there a data transfer cost for read replicas? Well, read replicas, as I mentioned, currently it's not possible to deploy in a separate region. So all your traffic that going between the primary and your secondary will be in the same region. So that's number one. And that's really it. So let me jump back to my slide because we have just a few minutes left, and I really want to hit the security portion because this is very, very important. And give me 1 second. All right. So we've talked about CloudWatch metrics being hypervisor level metrics. Here's the entire list. We've talked about enhanced monitoring, and we said that these are agent-based operating system level telemetry collected by that agent sitting on the operating system. And we took a look at the performance insights. And again, great tool, no cost if you collect and keep up to 7 days worth of telemetry. Great tool to work with. And so we've looked at the performance insights and CloudWatch metrics. And with that, let's talk about security. So security is very, very important. And here at AWS, we say security is job zero. Everything starts with security. Before we wrap our heads how to build something, the first question is how secure are we? How secure it is. So in the context of database workload, obviously security can be and should be configured and addressed at the multiple levels. So the first level is network, right? Here you've got your VPC, your virtual private cloud, which is again isolated version, fully isolated part of your AWS cloud. Here you control your subnets. You control your subnets through the route tables. You design your network topology where you have the private and the public subnets. And you also have access to NACLs. NACLs stand for Network Access Control List. And essentially, that's another great tool similar to that of the security group to control the traffic that's going between the subnets. Now, security groups, we've talked about this, and we even looked at the way I reconfigured my security group, and essentially we said that this is nothing but a virtual firewall that lets you configure your protocol and your port. Public access, obviously, try to avoid it at any cost. And for the securing your traffic, SSL is very much supported, on RDS. So the second level, how you address the security is obviously a security of securing your data. Here on RDS, we support all the native SQL Server built-in security features like TDE, always encrypted. That's all supported, as well as EBS encryption that I showed in my demo. And again, EBS encryption is very similar to that of TDE in the sense that it's using the same algorithm, but whole lot easier to set up and much more lighter weight in the context in terms of the performance overhead. All right. And last topic I really want to talk about is the support of Windows integrated authentication. And the common scenario here is, hey, I'm running my SQL Server on prem or on EC2, and I also have my Active Directory deployed. I'm contemplating of utilizing your RDS, but I have no intention of giving up my Active Directory. And that is very much supported case. The only additional step is here in the middle, and that requires you to launch AWS managed Active Directory and establish one-way trust between AWS managed and your self-managed directory. And after that, you can join your RDS instance to the AWS managed Active Directory and take full advantage of Windows integrated authentication. With that, I think we're coming up to the bottom of the hour. And Aditya, do we have any questions unanswered so far?
No, I think we got most of them, and we're at time anyway, so we're just let people take the polls here.
All right. So with that, thank you very much for your time. Thank you very much for listening to us. And again, as a reminder, that was a third episode in the series of episodes called Move to Managed. And our next session will be this upcoming Wednesday from 1 p.m. To 2:30 Pacific time. And we're going to be talking about how you migrate your self-managed SQL Server workloads over to Amazon RDS. So please join us. With that, thank you very much.